This is Tech Math 2. And we're in sections 13.3 and 13.4 today. 13.3 has to do with double angles. So we have new formulas, all of which are in the back of your book that you don't have to memorize. So if I have the sine of 2 theta, I'm going to have sine theta, 2 sine theta times cosine theta. And if I have the cosine of 2 theta, then that can be cosine squared minus sine squared. Or it could be 2 cosine squared minus 1, or it could be 1 minus 2 sine squared theta. And the way we change from the top guy to the other two guys, we remember that cosine squared plus sine squared is 1. And so if we replace either one of those, we get those other two formulas. And then the one that I never can remember, which is the tangent of 2 theta. So I end up looking up the tangent guy all the time. And
you push that buttons.
okay, there we go. Tangent of 2 theta, 2 tangent theta, 1 minus tangent squared theta. And I'm sure there's proofs for each of these, and I don't remember what they are. And then then we have half angles, so we have the sine of theta over 2, plus or minus the square root of 1 minus cosine theta over 2. And cosine of theta over 2, plus or minus the square root of 1 plus cosine theta over 2. And where's the half tangent? Tangent theta over 2, 1 minus cosine theta over sine theta. And again, you're not going to remember any of those, but remember that if you need them, they're in the back of the book. You go and get them. On page 461, there's another 8 formulas, which I'm not going to write down, which are derivations using the half and the double angle formulas and the formulas from the last section we did yesterday, combining them together. So we have sine plus sine and sine minus sine of double angles and things like that. All kinds of weird things. Okay, well anyway, now we're going to solve some problems knowing that we're doing that. Now, the double angle and the half angle formulas are going to be used in your physics classes next semester. So there will be problems that you'll end up having to use them. And when you get there, you'll say, oh yeah, I remember that. All right, so we'll start with number 1. 2 sine x over 4 cosine x over 4. And because we're in this chapter, we can just write down the answer as sine x over 2. Right? Because the sine of 2 theta is 2 sine theta cosine theta. And so x over 2 times 2, well, I guess not. 2 times theta. Yeah, and theta is x over 4. So 2 times x over 4 is x over 2. Anyway, did I do that wrong? All right, we'll look at number 2. 20 sine squared x cosine squared x. All right, well, what are we going to do with that? I don't know. I don't recall there being something with sine squared and whatever squared, right? All right, well, if I had 2 sine x cosine x, and I squared it, I would have 4 cosine x sine x, right? And if I put a 5 out there, now I would have 20 sine squared x cosine squared x, right? And now I look at the center thing, and this is just 5 sine 2x squared. Good thing I'm not wearing a long sleeve shirt, otherwise there'd be something suspicious going on. But there's nothing up my sleeve, there's nothing suspicious going on. Number 3. I have 1 minus 2 sine squared 3x, and I notice that that looks like the double cosine formula, and the double cosine formula is 1 minus 2 sine squared, so this is going to be the cosine of 6x. Well, that was pathetically easy. What happened? Guess we'll move to 11. So I'm looking at 11. I got minus the square root 1 plus cosine 250 over 2. All right, well that looks like a half sine, half cosine problem. All right, so that's going to be the cosine of theta 250 over 2. So cosine of 125. And it could be plus or minus, so having a minus there is perfectly okay. All right, well, let's look at 15. 15? All right, we'll look at 15. 100, the sine of 30t cosine 30t. So this looks sort of like 2 sine 30t cosine 30t is equal to sine 60t. And now it's a matter of what do I need? I need a 50 out there, so I get 100. So I could put a 50 there, and now I would be done. Okay, we'll look at number 16. 15 sine x over 6 cosine x over 6. And again, we see that that's in the form 2 sine x over 6 cosine x over 6 would be equal to a sine of x over 3, double angle formula. And then it's a matter of what do I have to multiply by to get a 15 out in front, and that'd be 7.5. So I'd say that this would be 7.5 sine x over 3. All right, now we get to the cooler ones, 18. Find the sine of 2 theta when the cosine of theta is 3 over 5 in the first quadrant. Okay, so cosine theta 3 over 5, and I'm in the first quadrant, so that means x is equal to 3, that means r is equal to 5, that means y is equal to 4. We have a 3, 4, 5 triangle, so the cosine of theta, the sine of theta is going to be 4 over 5. All right. So now we want to find the sine of 2 theta, which by definition is 2 sine theta cosine theta. And I know what the 2 is, and I know that sine theta is 4 over 5, and I know that cosine theta is 3 over 5, and I know I can multiply 8 times 3, 24 over 25. And it'd be a second quadrant answer, and the sign is going to be positive in the second quadrant, and I am done. Okay, did I leave enough out? Number 20. I want to find the sine. Alright, so I want to find the sine of theta over 2, where the sine of theta is minus 5 over 13 in the fourth quadrant. Okay, so I'm in the fourth quadrant, so that means I'm here at minus 5, and I'm there at 13, and I recognize that as a 5, 12, 13 triangle, so I know the x size is 12. So the cosine of theta is going to be 12 over 13 in the third quadrant. All right, now I need the sine of theta over 2. So I go to the half angle formula, and I see the sine of theta over 2 is going to be plus or minus square root of 1 minus the cosine 13 over 12. 12 over 13 divided by 2. All right, well, that's going to be plus or minus, that's 1 over 13. That's the square root of 1 over 26. So we call that plus or minus 1. No, square root of 26. 26 over 26. Okay. And then we say, well, is it going to be plus or minus? Because am I a second quadrant answer, or am I a third quadrant answer? I should be able to figure out which one it is. So it's going to be an angle that's steep into this way. So when I divide it by 2, it should be up there, right? Because if it was all the way this way, it'd be there. So this is going to be a second quadrant answer. So my answer would be a positive. So for my final answer, I'd have the square root of 26 over 26, because I rationalized my denominator. Okay, good enough? Let's move on to 43. Prove the identities. Okay, I'll prove the identity. I'll prove this identity. 43. Okay, so I've got the sine of theta over 2 minus the cosine of theta over 2 squared is supposed to be 1 minus the sine of theta. Now, we have a choice. We can manipulate the right side or the left side. I choose the left side because there's more there to manipulate. So I look at the sine of theta over 2, and I see that that's plus or minus square root of 1 minus cosine theta over 2 minus the cosine of theta over 2, and I see that that's plus or minus the square root of 1 plus cosine theta over 2, and I'm supposed to square it. I look at that and I say, well, this is the difference of two things that I'm squaring, right? So that means I'm gonna have a squared plus 2ab plus b squared. It's actually going to be minus 2ab. Minus 2ab. All right, so that's what I'm going to end up with. All right, well, if I do that, I'm going to have the plus or minus goes away in the first case, and I got 1 minus cosine theta over 2. And then the b squared guy, we'll do him next. He's going to be minus 1 plus the cosine theta over 2. And now I'm going to have the minus 2 times the AB. So it could be plus or minus the square root of 1 minus cosine theta over 2 times plus or minus the square root of 1 plus cosine theta over 2. And when I get done, I want to be 1 minus sine. Okay, well, that's where I'm heading. All right, well, I've got 1/2 minus 1/2. So he goes away. I've got minus cosine over 2. So this guy is going to be minus cosine theta. Now what do I have over here? These guys are multiplying together. And I'm going to put the plus or minus there, because it could be plus or minus, because I could be multiplying plus times plus, in which case it's minus, or plus times minus, in which case it's plus. Okay, so I've got 2 square root of 1 minus cosine times 1 plus cosine divided by 4. And that's supposed to be 1 minus sine. It's supposed to be 1 minus sine. Am I getting any closer? I got a 2 there and I got a 2 there. Okay. So I got minus cosine theta plus or minus square root of 1 minus cosine squared theta. Is that what I got? Yeah, I do. And then I remember that 1 minus cosine squared theta, 1 minus cosine squared theta is sine squared theta, right? I think I remember that. Do I remember that? So 1 minus cosine. 1 minus cosine. Okay, so this is minus cosine theta plus or minus sine theta. And that's supposed to equal 1 minus sine theta. And I don't see it. Do you see it? I don't see it. So either I made a mistake or there's no way this is not equal. Those are the two possibilities. All right. So we could go back up and see where I think I made a mistake. Oh, I don't see anything wrong. Do you see anything wrong? I didn't think so. Okay, moving on to 13-4. Now 13-4 is one of those that Benjamin's going to love. He's never going to get these problems right. So that's one of those things. Because they're going to be multiple answers and you're only going to be thinking about one of them. So let's say that I have sine of theta is 1/2. What is theta equal to? And you say, well, 30 degrees, right? Yeah, pi over 6, right? And I say, okay, minus 1/2. Why minus 1/2? Well, if I look at the sine function, it goes up, it goes down, it goes up. There are two answers where I'm at 1/2. So I'm at 1/2 in the first and the second quadrant. So theta, the correct answer, theta would have to be 30 degrees, or it would have to be 150 degrees. I'd have to get both of them. Okay. So this problem set has me looking at 0 to 360 degrees. So I have to get the other solution. So if I had cosine 4 theta is equal to 1/2. I say, well, I take the arc cosine of both sides. 4 theta is equal to 60. Theta is equal to 15. And I circle that and go on. All right, well, that'd be minus 7/8, because you're missing 7 answers. Where's the other 7 answers? You're supposed to be looking between 0 and 360, and the period of 4 theta is 2 pi over 4, which is pi over 2, which means between 0 and 360, I have to go down, up, down, down, up, down, up, down, up, down, up, down. And now, if I look at a half, I go across there, and there's 1, 2, 3, 4, 5, 6, 7, 8 answers I'm looking for, and I only found one. So, and we covered that earlier today before Ben walked in, saying that there's no way Ben's going to get these right. And number 3, now you can put them in your graphing calculator and move your cursor up and down to find the spot where it is. So that is a possibility too. All right, so we're doing problem number 3, and we say that the tangent of x is equal to, let's say, minus 1 is equal to 0. All right, so the tangent of x is equal to 1. And if we take the arctangent of both sides, we get 45 degrees over here, and on this side we get x. So x is equal to 45, right? But the tangent function goes 90 to 90, and he does that. And then he does it again. And then he does it again before we get to 360. So that means there's going to be 2 answers to the problem. One answer is going to be in the first quadrant. The other answer is going to be in the third quadrant. All right, well, if 45 degrees is the reference angle, then the third quadrant answer has to be 180 plus 45, which is 225. So final answer, x is equal to 45. X is equal to 225. And then I can just put it in my calculator and say, well, what's the tangent of 45? Tangent 45 is 1. I could have told you that. And tangent of 225 is 1. So my calculator tells me I'm right, but if I didn't draw a good enough graph to know there was 2, then I'd be pretty much whole city there. We'll try number 5. 4 cosine squared x minus 3 is 0. All right, so cosine squared x is equal to 3 over 4. Cosine x is square root of 3 over 2. Is that correct? Yes or no? Correct? Show of hands. How many thinks that correct? Nobody thinks it's correct. How many thinks it's wrong? Okay, Ben's the only one that raised his hand for correct. It's wrong. It's plus or minus the square root of 3 over 2. All right. So now I take the arc cosine. You knew it was wrong. You just didn't know why. Of x, and the arc cosine, we'll just take the positive guy. Square root of 3 over 2. And we know that that is 30 degrees, right? So x is equal to 30 degrees. And now I look at the cosine function, and it goes down, it goes up, it goes down, it comes back. So I'm going to have 2 answers, square root of 3 over 2, 2 different places, there and there. But I also have to look for minus the square root of 3 over 2, so that's going to be 2 more answers there and there. All right. That being the case, x is going to be equal to 30. I got that one. That's my reference answer. Now, my second quadrant answer is going to be 150, right? 180 minus 30. Third quadrant answer, 180 plus 30. And fourth quadrant answer, 330. 360 minus 30. And then I go back and say, okay, well, what the heck is the square root of 3 over 2? Anybody know? Square root of 3 divided by 2. So that's 0.866. So now I go and find the cosine of 30. That's right. And then I look at the cosine of 150. That's the same thing. and then I look at the cosine of 210, and thank you very much, cosine of 210, and so that works. Cosine of 330, that works too. Okay, so all my answers check. Well, some of them are positive, some of them are minus. But if I didn't follow that x squared is equal to 4, x is equal to plus or minus 2, when I take that square root, then I wouldn't end up with the negative answers. I'd only end up with 2 of the positive answers. And that would be minus a half, naturally. We'll do 16, and then we'll go plus or minus, then we'll go 0 to 2 pi. Right now it's going 0 to 360. So number 16, cosine squared x minus 3 cosine x is equal to plus 1. Plus 1 is equal to 0. Okay, did I write the problem down right? Okay, well, I look at that and I say, well, gee, that's just y squared minus 3y is equal, plus 1 is equal to 0, and I can factor that y plus, no, I can't. Why can't I factor that? I can't factor it. Bummer. That means I have to use quadratic formula. Okay, so I'm going to use quadratic formula and say cosine x is equal to minus a minus 3 plus or minus the square root of minus 3 squared minus 4 times a times c divided by 2a. I think so. Cosine x is going to equal 3 plus or minus 9 minus 4, the square root of 5 over 2. Well, isn't that just lovely? All right, so I'm going to take the, I'm going to say x is the arc cosine of 3 plus the square root of 5 over 2. I don't think there's an answer there. Do you think there's an answer there? 3 plus the square root of 5 divided by 2. And there's no answer there because there's no, the arc sine of 2.6 is undefined. So there's no answer at the plus guy. And then I look at the arc sine of 3 minus the square root of 5 over 2. All right, so 3 minus the square root of 5 divided by 2, which is going to be the arc sine of 0.381966. All right, and then I'm going to go and take arc cosine of my answer, and I end up that x is going to be 67.5 degrees in the first quadrant. Okay, then I ask myself, so the positive answer isn't there, so that means I only have a second quadrant answer to look for. No, this is cosine. So I'm looking for a first and a fourth quadrant answer. Okay, so there's my first quadrant answer. My fourth quadrant answer would be 360 minus the answer. And so that'd be 292.5 degrees. So my final answer, we put a solution set around at 67.5, 292.5, and then we'd ask ourselves, is that right? Alright, so come back to the original problem. The cosine of 292.5 squared minus 3 times the cosine of 292.5 plus 1 equals, yeah, pretty much 0. All right. Wasn't that exciting? Totally exciting. All right, we get to do it again, and but this time we're doing it with 17, and 17 we have to consider 0 to 2 pi. Okay, so we want our answer to be in radians this time. All right, so 2 cosine squared x plus sine x is equal to 1. Oh, what am I going to do with that? Well, I know that cosine squared x is 1 minus sine squared x, right? So this is 2, 1 minus sine squared x plus sine x minus 1 is equal to 0. I've got a 2 and I got a minus 1, so I'm going to have a 1. I'm going to have a minus 2 sine squared x plus sine x plus 1 is equal to 0. Can I factor that? Yeah, I should be able to factor that. I've got minus 2 sine x. I have sine x. Okay, I've got a minus 1. I've got a minus. I didn't factor. Yeah, that factored. Didn't that factor? Yeah, I got minus, I got a plus, and I've got a plus. So yeah, that factored. Okay, so I have 2 possibilities. Case 1, sine x is equal to 1. Okay, well, I look at the sine function, and that only happens at one point, pi over 2. So that's one of my answers. Case 2, minus 2 sine x minus 1 is equal to 0. All right, so sine x is equal to 1/2. Okay, well, we know that happens at pi over 6. No, it's not minus 1. No, yeah, it is minus 1. As I say, minus 1/2. The arc sine of minus 1/2 is going to give us 360 degrees, right? So there's going to be a 4th quadrant answer, and there's going to be a 3rd quadrant answer for that, right? Because the sine function does this, so I need 2 different answers. So now I'm looking for the 3rd quadrant answer, 210, 210. All right, so x is going to be, well, we can't use those because we have to keep them in pi's. Okay, well, this is, all right, so we got pi over 2 is our first guy. Our next guy is something over 6. 11 pi over 6, 11 pi. Now this is where if you memorize the unit circle I gave you last time, you know, life is so much better. And this is going to be 7 pi over 6. Okay, so those are my answers. Now those are going to be difficult to check in my calculator, so I'm going to check the 2, well, I could change the pi, I suppose. But I'm going to check the 210 guy. So 2 times the cosine of 210 squared plus the sine of 210 equals to 1. Yes, it does. So the 210 guy checks, yes. The rest of them are going to check too. And the pi over 2 guy, well, if I put pi over 2 guy, he becomes 0, and pi over sine of pi over 2 is 1. So he checks too. So we assume they're all going to check. Okay. We need something that's more challenging. Like 19? Is 19? I only have 10 minutes though, so it can't be that challenging. We better drop down to 24 just in case, because we obviously want to do 24. Cosine 2x minus 2 sine squared 2x plus 1 is 0. Okay, well, cosine 2x is equal to something, right? What was it equal to? I think it's like 1 minus something like that. Cosine 2x. So cosine 2x is going to be 1 minus 2 sine squared theta. Well, that definitely doesn't help any. Minus 2 times the sine of 2x is going to be 2 sine theta cosine theta squared plus 1 is 0. Well, that's convenient. Now the 1's go away because I got a 1 there and a 1 there. Okay, so now I've got minus 2 sine squared theta minus 4 sine squared theta cosine squared theta. And that's supposed to be 0. Now, cosine squared is 1 minus sine squared, right? So minus 2 sine squared theta minus 4 sine squared theta times 1 minus sine squared theta is equal to 0. All right, so now I got minus 2 sine. Is there an easier way to do this that I'm not saying? Minus 4 sine minus 4 minus 4 sine to the 4th theta is equal to 0. Right, so I got minus 6 sine squared plus 4 sine to the 4th has to be 0. Well, this is obviously pretty simple, right? So I got sine squared theta times minus 6 plus 4 sine squared theta is equal to 0. Okay, so the first case, he's equal to 0. He's equal to 0 at pi and at 0. All right, so that's that guy. Now we're worried about this guy. Minus 6 plus 4 sine squared theta is 0. Sine squared theta is 6 over 4. 6 over 4. All right, so sine theta is the square root of 6 over 2. Now, well, we might not have to worry about that. Is the square root of 6 over 2 greater than 1? And if I calculated it, come on, I'd know that. Square root of 6 divided by 2 is greater than 1. So this is no solution. You're right, there's a plus or minus there, but there's also no solution here. So the only solution we have is theta is equal to pi in 0. Now, did I make the mistake? Oh, good, this is even. Because if you're
Not at the top of that problem.
What?
Right at the top.
Way to the top. Did I write it down wrong?
Well, you got cosine 2x. How do you go from the cosine 2x to what it says?
Page 456,
Right.
equation 25c. It says cosine of 2x is 1 minus 2 sine squared theta.
That's cosine of
So cosine squared theta. Okay, got that? Now we got to go back and check our answers. So we're saying 0. When I put a 0 in here, that makes this a 1. And 1 plus 1 is equal to 2. So the 0 answer is wrong. Okay, when I put the pi answer in, I get 2 pi. This becomes 1 again. That becomes 0. And it's wrong too. So neither of my answers work. They're both wrong. So there may not be any solution to this problem. Well, we can try numeric solve on my calculator. Numeric solve cosine 2 times x minus 2 sine 2 times x. Oh, I didn't put a times there. Well, we're not going to bother. I'm pretty sure that is the issue in this problem, is that there's no solution. 33. Now I got to get 33 to check with the back of the book. So that means I'm going to have to pay more attention. 1 plus cosine squared x over 2 is equal to 2 cosine x. Okay, now cosine x over 2. Cosine x over 2. Okay, so this is going to be 1 plus the square root of 1 plus cosine x over 2, the quantity squared, is equal to 2 cosine x. Alright, so I've got 1 plus 1/2 plus cosine x over 2 is equal to 2 cosine x. I got that 3 over 2 is equal to 3 over 2 cosine x. I have that cosine x is equal to 1, and that only occurs in one time, right? That only occurs one time. So x is equal to 0. X is equal to 0. Go back to the original equation. If x is 0, then this guy is going to be 1. 1 plus 1 is 2. And I got 2 on the other side. Okay, and then we'll just run to the back of the book, 13.4 in the back of the book, to see if the instructor is lying or not. I mean, pulling the wool over our eyes too far. 13.4. Okay, there's 13.4, number 33, and the answer is 0. Oh, I don't believe it. Look at 27. 1, 2, 3, 4, 5, 6, 7, 8 answers to 27. We should have done 27. That would have been more fun. But with only 1 minute to go, the chances of coming up with 8 answers are going to be slim and none. Okay, so the problems on the quizzes and the tests that deal with these types of problems will always have multiple answers. And the worst case scenario has, I think, 12 of them. Worst case scenario. But that's all right. It's just 1 point. You're just going to blow it off anyway, right? Yeah, probably. Okay, questions? Thoughts? Comments? Yeah. Why didn't they tell me this in 12th grade? I don't know.